Continuing 6.4, today you're going to get two new factoring friends. Very exciting. So head on down. Yesterday, or in our last video, we learned about the quadratic form. That was a new factoring friend. And today you're going to get the sum of two cubes and the difference of two cubes. And the patterns are very similar for factoring these. Friend number 7, sum of two cubes. Anytime you have two cubes being added together, you can factor it into the product of two polynomials. The first one is a binomial and the second one is a trinomial. And notice the sign here. So I think the best way to explain this is to actually do an example with you. So let's look at our function s of x. This in fact is a sum of two cubes because I can write x cubed as x to the third power. In other words, the cube root of x cubed is just x. That is going to be my a. And then I can also write 27 as something cubed. That's right, it's 3. And so that 3 right there, that is the base that is being cubed, or the cube root of 27. And that is going to be my b. Now, factoring this is very simple. I'm just going to follow the pattern up here. So s of x will be factored into a plus b, right, or the cube root of both terms. So x plus 3 times, and now I'm going to follow the pattern on the second polynomial. You take the cube root of the first term, or x, which is my a, and you square it. You subtract. Now you take both cube roots, so my x and my 3, or my a and my b, you multiply those together, 3x. And then you add to that the cube root of the last term, right, or 3, or b, and you square that. Okay, so completely simplified, you'll have x plus 3 times x squared minus 3x plus 9. That is completely factored for this problem. Now you may still be able to take, like if you have a trinomial that can still be factored, notice this is a quadratic, but I don't think that I can factor, there are no factors of 9 that'll give me 3, right? That'll add or subtract to 3. So I think I'm done there. So to solve this, we are now going to set my output equal to 0. I'll have x plus 3 times x squared minus 3x plus 9. I'll use my zero product property and set each one of these equal to 0. I can subtract 3 from both sides here and get the fact that x is going to equal negative 3. Now, how do I solve this quadratic that's not factorable? Well, you have some options. One of them is quadratic formula. And before I even start the quadratic formula, I'm going to see if there's any real solutions here to begin with. So I'm going to use that discriminant, that b squared minus 4ac. Let's see what we get here. So that would be negative 3 squared minus 4 times 1 times 9. So that's 9 minus 36, which is a negative number. So how many solutions are there? There are no real solutions. So when you graph this cubic, the only solution that you're going to have is x equals negative 3. So just super quickly and for fun, because again, we'll be going this direction eventually. Let's see. So I know I have an x-intercept at negative 3. My y-intercept has to be 27. My end behavior is opposite, down on the left, up on the right, since my leading coefficient is positive. This is going to be a cubic function that only has one x-intercept. Maybe it looks something like this. I'm not 100% sure. It may have some other critical points. I don't know 100% about that, but I did find the root. So solving it, you only have one solution. And our last new friend, friend number 8, difference of two cubes. The pattern is just like the sum of two cubes. The The only difference is that there's subtraction. So in the binomial, that's where the subtraction sign is. Notice the trinomial, all the signs are positive. So let's go ahead and let's factor the function d of u. Now, when I look at d of u, I don't think those two terms are perfect cubes. I can't take the cube root of 16. There's nothing times itself 3 times that'll give me 16. So don't forget about friend 1, greatest common monomial. I believe that these two terms have a greatest common monomial. They're both divisible by 2, and they both have a u squared. So I am first going to factor out a greatest common monomial of 2u squared, which then leaves me with 8u cubed minus 125. That looks better. 8u cubed is in fact a perfect cube. This is 2u cubed. And 125 is also a perfect cube. It is 5 to the third power. So 2u will now be my a, and 5 will now be my b. When I continue to factor this, I keep the greatest common monomial. And now I follow the pattern. So my a is 2u. So I'm going to have 2u, and my b is 5. So minus 5. Now I take my a and I square it. So I'm going to have in my parentheses here 2u squared. Then I add to it a times b, or 2u times 5. And I add to that b squared, which is 5 squared. All right, simplifying this, I've got 2u squared times 2u minus 5. Now 2u squared is really 4u squared. And 2u times 5 is really a 10u. And 5 squared is really a 25. Now I need to ask myself, is that completely factored? And I don't actually think it is. I'm looking at this trinomial here, and that looks like a perfect square trinomial, right? First term could be 2u squared. Last term would be 5 squared. And if I took those two together and doubled it, I don't think it is. That would end up giving me 20u, which, so I lied. That is not a perfect square trinomial. It cannot be factored any further. So this is the complete factorization. Always good to go a step further and just double check. I'm going to come down here and solve it. Give myself a line here. And I'm going to skip the step of plugging 0 in for d of u and rewriting the whole thing. I'm just going to set every single factor here equal to 0. So 0 equals 2u squared, 0 equals 2u minus 5, and 0 equals 4u squared plus 10u plus 25. All right, so solving this, I got u squared equals 0. Guess what kind of root I have here? I have a double root. So I know that at x equals 0, I'm going to have a double root. Again, we'll learn more about that in the future, but it's good to kind of tie it all in. Okay, this one's going to be an x-intercept of 2.5. Oh, and then I don't know about this one. Let's see, is there any real roots here? So that's going to equal 10 squared minus 4 times 4 times 25. Well, once again, I think this is 400, negative 400. So that's a negative 300. So we don't have any real solutions tied to this trinomial. So my only real solutions are going to be u equals 2.5 and u squared equals 0, which is a double root. Just for fun, I think we should do a super small graph of this. I know I have a double root at 0. That's going to mean something. I have another root at 2.5. The end behavior here, well, let's see, it's going to be opposite directions and down on the left, up on the right, based on the degree and the leading coefficient. Now watch this. Down on the left, it's going to come up, it's going to touch that double root, but it's not going to cross the x-axis. It's going to be tangent and turn back around. Somewhere it'll turn back around, go through my actual single root. So I actually only have 2 visual roots. But the end behavior is correct. Again, I don't know the exact critical points, and I could plug in other points to find more points if I needed to. Moving on to example 3. A manufacturer wants to build a rectangular stainless steel tank with a holding capacity of 500 gallons, or about 66.85 cubic feet. If steel that is 1/2 inch thick is used for the walls of the tank, then about 5.15 cubic feet of steel is needed. That talks about the width of the walls. The manufacturer wants the outside dimensions. So the outside dimensions, not the inside dimensions, the outside dimensions of the tank to be related as follows. The width should be 1 foot less than the length. The height should be 9 feet more than the length. So notice everything's based on the length. So maybe we let the length be x. Then we'll let the width be 1 foot less. And we'll let the height be 9 feet more. All right, so talking about the volume of this rectangular prism, remember the volume is always length times width times height, or any combination that looks something like that. So what should the outside dimensions of the tank be? All right, so we want the actual outside. Even though the inside needs to be 66.85 cubic feet, we're actually going to have some walls that are thicker, which is going to create an additional 5.15 cubic feet of steel being needed. So we're going to add these two numbers together to get our entire volume. All right, so we know that our volume in this case needs to be 66.85 plus 5.15. And I believe that is 72 cubic feet. Well, let's use that 72 cubic feet, plug it into our volume formula, and we'll also plug in the length, the width, and the height. So I know that 72 will equal, well, x, and it doesn't really matter the order, again, it's multiplication, times x minus 1 times x plus 9. So multiplying this all out, I think I'll multiply the two binomials first, leaving me with x times x squared plus inners and outers give me a positive 8x, last give me negative 9. Now I get 72 equals x cubed plus 8x squared minus 9x. We'll put it in standard form by subtracting 72 from both sides. I get 0 equals x cubed plus 8x squared minus 9x minus 72. Now I'm going to try and factor this polynomial. First, I'm going to look for a greatest common monomial, and I don't see a greatest common monomial in all 4 factors. However, I do see 4 factors, and I see some common factors in each grouping here. And I think I'm going to go ahead and group that negative with the 9. So it'll be a negative 9, and then I'll add those two groupings. Let's see if I can get a common binomial factor here. So I'll factor out an x squared, leaving me with x plus 8. And I'll factor out a negative 9 in the second grouping, leaving me with x plus 8. That is fantastic. So you guys should see we've got some common binomial factors there that I can now factor out. So I will now have 0 equals x plus 8 times, well, what's left? In the first term, I've got an x squared, and in the second term, I have a negative 9. Okay, all I've done so far is factor. It is time to start solving it. How about we come over here? So take each one of these factors and set them equal to 0. Let's start with that one. Subtract 8 from both sides. I get x equals -8. All right, let's do the other factor. X squared minus 9. I'll add 9 to both sides. X squared equals 9. So if I take the square root of both sides here, I'm going to end up with two answers. X can be positive or -3. Okay, now this is a word problem, and it's got a real world answer, so we need to make sure that we have a real world answer. The question is, what should the outside dimensions of the tank be? Can I have a width or a length or a height that is negative? No. So any of my negative solutions are what we call extraneous. I'm going to throw those out. So instead of having x equals positive or -3, I am just going to keep the +3 answer. So I know that my, I'm confused, let's see, width should be 1 foot less than. So my width here is going to be 1 less than, and my length, right? So that means that my length I made be 3. My width then has to be 2. And my height needs to be 12. So my dimensions are 3 by 2 by 12, and those would all be feet.